Hey, it's Tony from Adafruit, and in this video I'm going to look at how to use the MicroPython port for the ESP32. And so the ESP32 is a new version of the popular ESP8266 Wi-Fi microcontroller. So this is a really cool new version that adds a lot of new features. I think it has 2 cores, it has better Wi-Fi support, eventually things like Bluetooth Low Energy, faster, more memory, all kinds of things like that. And the great thing is there's a port of MicroPython that's still in early development, but it is possible to start using it now. But you do have to kind of build it yourself and load the firmware. It's not as easy to use. You can't just download a pre-built firmware yet because, again, it's kind of early days for it. But in this video, I'll walk through how to compile the firmware for MicroPython ESP32 and how to load it onto a dev board. We'll just play with it a little bit and maybe like blink an LED, turn some things on and off and see how it works. So we'll just kind of dive in here and get started. Oh, and also I should mention, I was kind of inspired by this. There was a hackaday.io hack chat, and it's actually might still be going on right now today with one of the engineers that works at Espressif. That's the company that makes the ESP8266 and the ESP32. So they were doing an interesting little hack chat about the ESP32 processor. And so I thought, oh, this is a good time to check out MicroPython on here, because just in the last month or so, Damien George, the creator of MicroPython, has created a port of MicroPython to the ESP32. And I think I mentioned this in the adafruitdaily.com MicroPython newsletter a little while back. And if you aren't signed up, check out adafruitdaily.com. Every week we have a little MicroPython newsletter. So anyways, let's just kind of dive in. So like I said, this is a brand new port. It's still a little bit early in development, doesn't support everything yet, but let's get it loaded and see how it works and what we can do with it. So we'll jump into the main view real fast here. We'll go into the desktop view. There we go. And what we've got here, so in the upper right-hand corner, this is an ESP32 dev board. This is actually, I think, like one of the early proto boards. I've had this for a little while, but haven't really had a chance to play with it much yet. And then on the left right here, this is the web browser, and this is a link to where you can buy this board right now if you want. So this is just a dev board for the ESP32 processor. Mine actually doesn't have, there's a little metal cap that goes on top of the main ESP32. This little black kind of square is actually the ESP32 board. And then the blue part here is the little dev board that's built around it, because just like the ESP8266, which I probably have one right here. Let me see. That's a SAMD. Yep, here we go. Here's an ESP8266. So like with the ESP8266, so like with this guy, or actually here, maybe I should show it right here. You can see, again, there's this little, the ESP8266 is this little chip right here, this board, and it's actually underneath this metal can. And then everything else around here is the dev board that supports it, because you need to add a USB to serial converter to talk to this chip. And even on the ESP32, you still need that. It doesn't have native USB support built into it like other microprocessors. But anyways, this is, from what I can tell, probably the most popular ESP32 board. But keep an eye out. I'm sure there'll be a lot more chips coming out because this board is starting, or this the ESP32 is starting to mature to the point where I think it's going to be almost as easy as the ESP8266 to start using it. So, things like Arduino, there's a port of that so that you can start programming it with Arduino IDE. So as it gets easier, I think it'll get more popular and more people start using it, and then you'll see a lot more dev boards and things out there. But this is where you can pick it up. And again, I should preface this to say that, a lot of things are still in early development with it. It's not as complete or as well documented as maybe the ESP8266, but it is documented pretty darn well, and there's a lot of stuff out there for it. If you do want to play with it and you don't want to use MicroPython, like I mentioned, there is a port of Arduino to the ESP32, and I'll put a link in the description when this goes up on YouTube, so look down below and I'll have links to all of these things here. And you can, oh, my cat is trying to pull some wires down somewhere. Anyways, so you can set up the Arduino IDE to program this chip using Arduino libraries and things. I tried it out right before the stream and it works great. So just follow the instructions on this page right here. Basically, you just install Arduino and then you go and run some commands in a terminal. You might need Python installed if you're on Windows. And then it seems to work well. You can select your board and upload, and I got like a basic kind of hello world to work. The really useful thing about this page, though, is the very bottom here, and this is useful even with MicroPython. For this dev board, it shows the pinout here, so you can see like, okay, you know, GPIO 32 is this little pin right here, and that happens to be maybe one of the analog to digital converters. So this is really handy, and I'll reference this later when we look at when we get MicroPython loaded on here. Okay, so to get started with MicroPython, we'll need to get the MicroPython source code because basically there's not a pre-built version of this firmware yet because it is really early in development. I think it's just within the last month or so that this port was actually created. So it's moving target. It changes. It actually just changed 2 days ago. I think Damien just made some little tweaks and things. So again, you're probably going to want to check this GitHub repository. So I'll put a link to this GitHub repository. This is under the MicroPython GitHub account, which is where all of MicroPython has its source code, but it's under a special MicroPython-ESP32 repository. So it's not under the main MicroPython repository. And I think that's just because the creator, Damien, I think he wanted to keep it separate while he kind of stabilized it and got it working. And eventually, I'm sure it's going to get ported back into the main repository. And if in the future, if you're looking at this and you don't see this MicroPython ESP32 port, then maybe it was merged back in and you probably want to look at the main MicroPython repository. Okay, so if you look at this repository, it's just the basic MicroPython repository and it doesn't really tell you a lot right here because it hasn't been updated. But dive into the ESP32 folder. That's where each port of MicroPython or each platform has a subfolder. And so the ESP32 folder is where all the action is for this port. And it actually has a really nice README right here. So Damien's put some nice work into this that explains exactly what you need to do to get this thing set up and running. Again, so there's no pre-built binary. You know, there's no release under here that I saw. At least I don't think there was a release. So let's go back up to the main page here. Yeah, so you can see, oh, maybe there's a release? No, I don't think so. So, yeah, it just has a source. Okay, so there's no pre-built release, so we're going to have to build it ourselves here. But it's not that difficult, and I've actually made it really easy. I've made some changes to this little Vagrant VM virtual machine that I'd shown long ago how to build MicroPython for the ESP8266. I updated that virtual machine so that it can now build this ESP32 port. So it's pretty straightforward. But if you do want to set things up yourself, read what Damien has written here. So basically you need to install an Extensa cross compiler for your platform, and then you also need to install this Espressif IDF. It's like their development framework for the ESP32. And so it links to this GitHub repository right here for the Espressif IDF. And then here it actually goes into a lot of good instructions for each platform on how to set this up. And so for Linux, for example, you have to run some apt-get commands. You have to install this tool chain. Basically, you download a tar.gz file, you open up this archive, and then you have to set up your path to point at it because you need a compiler that can compile for the chip on the ESP32, and so that's what this does. Now, the cool thing is, like I mentioned, long ago, boy, probably over a year ago, I did this guide right here, and I'll put a link in the description below when this is on YouTube. And in this guide, I talked about how to build MicroPython for the ESP8266 because just even a year ago, actually, ESP8266 MicroPython is pretty much brand new, and you had to build the firmware just like I'm going to show for the ESP32. And I set up a little Vagrant. Vagrant is a tool that can simplify creating virtual machines. So I set up a Vagrant virtual machine that can compile the ESP8266 based source code, so things like MicroPython. And I went through and I just updated it, so now it will install all of the tools that you need for this Espressif IDF and ESP32 MicroPython. So follow this guide and follow the build firmware page right here. And this will tell you how to install VirtualBox, which is a virtual machine software. It's free, which is kind of nice. Vagrant, which is like a wrapper around VirtualBox that simplifies using it from a command line. It's also free, which is nice. And then you also need the Git source code tool. But follow this guide and it'll tell you how to set up this virtual machine. And if you already have this virtual machine installed, what you want to do is destroy your VM because you need to re-provision. So you want to re-download the Vagrant file, or like do a git pull if you've cloned the Git repository. Update the Vagrant file basically based on what this guide has right now, and then you want to destroy and recreate your virtual machine. Or if you just create it in a new directory, then it should re-provision it automatically if you're kind of confused there. Just that you need to make sure that you pull in the latest version of that Vagrant file, because I made some changes there to add in some extra tools that it needs to have installed. But anyways, the basic thing is you just want to clone this repository like the guide mentions, and then you'll run this vagrant up command. And I'm going to run this right now. Now, I've run this ahead of time, so it's going to be pretty quick. It's just going to start up my virtual machine. But the very first time that you run this, it's going to take probably about 30 minutes or so, because it will download a Linux image. And even if you're running Windows or Mac or whatever, it doesn't matter, because this is going to run in a virtual machine on your computer. And so it'll run a little Linux machine on top of whatever your operating system you're running. And then inside of that Linux machine, it's going to download all of those tools from Espressif. And it will set most of them up. It won't set all of them up, but I'll show you what you need to do after this. Okay, so my machine's provisioned. It's all ready to go. And then I'm going to run vagrant SSH. And this is going to connect me into the virtual machine. It's just going to give me a terminal here. It's going to be a Linux prompt for this. Okay, so now I'm connected. And if I run the ls command, this is going to list everything that's in the home directory for this virtual machine. And you can see there are a few new things if you've used this virtual machine before. There's this ESP-IDF folder. This is the Espressif IoT development framework, which the MicroPython ESP32 port needs. And then there's also this Extensa ESP32 ELF folder. And this is the compiler for the ESP32. And so the virtual machine went ahead and installed all of that for me ahead of time, which is kind of nice. So it's there and it's ready to go. But again, like I mentioned, you can follow in this GitHub repository for the Espressif IDF. It tells you exactly how to set this up manually. And that's all I did, and then put it into the Vagrant file for this. Okay, so at this point, and you might also notice in here there's a MicroPython folder, and that's because it clones the MicroPython source code when you build this or when you create this virtual machine. But again, be careful. This is the normal MicroPython source code. This is not the MicroPython ESP32 source code. And actually, if I go into this folder, you won't even see there's no ESP32 port inside of here. It doesn't exist. So if you run into some issue there, make sure that you aren't looking at the master MicroPython repository. Okay, so because I decided not to clone the ESP32 repo in the setup of this virtual machine, because I figured at some point this repository is probably going to go away. So, I don't want this video to go out of date completely. So in the future, you might just need to use that MicroPython repository. But for now, I need to clone this ESP32 repository. So again, there's a link that'll go in the description when this is up on YouTube, so you can find a link to this source code repository. But I'm just going to grab the link here that GitHub has, and then inside of the virtual machine, I'm going to run git clone, and then let's paste in that link. And so this is going to clone that MicroPython-ESP32 directory into my virtual machine. And so this has the source code for ESP32 MicroPython. And then once it finishes cloning it, then we'll dive in and we'll start compiling it. And it's actually pretty easy to compile it. Okay, so it just cloned it. And then like I said, we'll go back into that ESP32 folder, and then the README is what we'll continue following. So if you're using the virtual machine, basically you don't need to worry about this setting up the tool chain step. You can pretty much just ignore this first part right here because it's already done for you. Okay, so the next thing, now that I've cloned this, let's go into that MicroPython-ESP32 folder. And then this has the source code for ESP32 MicroPython. And then there's one step you need to do before you compile it. You have to make the mpycross tool. So run make-C, and I think it even mentions in here Yeah, so I'm just kind of follow this building the firmware steps in the README. So you want to run this make-c mpy-cross, and this will just go and build this mpy cross compiler tool. It's something that MicroPython uses internally when it builds all these frozen modules. It pre-compiles the MicroPython source code into bytecode, and it uses this mpycross tool to do it. But to bootstrap the whole process, you need to build mpycross, and so that's what you do. And you just have to do this once. And I think even if the code changes, it'll detect that it's different and rebuild it automatically. Okay, so that's done. And now the next step is we go into that ESP32 folder from within the MicroPython-ESP32 GitHub repository, because in MicroPython, each platform has a subfolder generally, and so this is the ESP32 platform for here. Now there's one little thing we need to do before we get too far into this. You do need to kind of configure your ESP32 build specifically for your board, and so it mentions up here before you can build the source code, you need to set, there's an environment variable, this ESP IDF environment variable. This has to point to the location of that ESP IDF IoT development framework. And then it also mentions you can set things like what's the name of the serial port that your dev board is connected to, and what type of flash memory does it have. Does it use this quad speed SPI flash or double speed SPI flash? What's the size of the SPI of the flash chip that's on your ESP32? Because just like the ESP8266, the ESP32 board has a little SPI flash chip, and it's what my finger's pointing at right here on this board. And it can differ between the different packages here. So you'll probably want to look at the board that you buy and see if it has like the specs that say what type of flash memory it has. This development board I have right here has a 32 megabit, which is actually pretty big. Most chips I don't think have that big of a chip. I think the biggest is usually like 16 megabit or so. But this one happens to have a 32 megabit that's configured with the dual SPI flash. So there's either QIO or DIO that you might see, and that's actually this flash mode right here. And it is important to know the difference for that. And unfortunately, to really know the difference, you're going to have to see the schematic, because it depends how that flash chip is wired to your board. But I'll show you, if you're not sure, you can try the DIO mode first, and if that doesn't work, then I'll show you can change it to QIO. For me, I started out, I tried QIO and it didn't work, and then I tried DIO and that worked. So apparently I have a DIO wired up chip right here in this case. So just a little thing to be aware of is that the mode and the size of your flash memory does matter, but it's not the end of the world if you don't get it right. It's not going to break anything as far as I know. So, you know, it's just your code won't run. You won't get the MicroPython REPL, and then it's kind of obvious then, okay, so I'll try it the other way, and it'll probably work that way. Anyways, long story short, there's some stuff you have to configure before you build this. And the easiest way to configure it, like it mentions in the README right here, is you can make a little make file that sets these environment variables and then invokes the master make file that compiles all of the MicroPython source code. So the way to do that is inside of that ESP32 folder, we're going to create a file called makefile, but be very careful. Run nano makefile with a lowercase m, because if I do this with an uppercase m, I'll do this the wrong way. You'll see there's a file that already exists here. So you want to use lowercase because we want to make a new file that's called makefile, and shares the same name as the makefile that's in here. But I'm just kind of following what the README explains here. So I mean, you could make a different file, but then you're going to have to invoke make with a different command. So just use a lowercase m makefile. If you do happen to see that some file already exists, then stop and go check the README, because maybe something changed in the repository and maybe there's a new makefile that's in there by default. But for now, there's no makefile, lowercase m makefile, and so that's kind of what's suggested here. And I'm just going to copy everything they have as the suggestion to add into the makefile, and then we'll modify this a little bit. So we paste this in, and so the very top line is this ESP IDF equals, and then you need to fill in the path to the root of that ESP IDF folder. And so for this virtual machine, it gets installed into the home Vagrant ESP-IDF folder. And so you want to set it to exactly this value here, and this trailing slash does matter, I noticed. So make sure to end it with a slash like this. If you installed it manually, you're going to have to put the location of that where you've installed it here yourself. Now uncomment the next lines, the next 3 lines, this port, flash mode, and flash size. So the port, this is going to be the name of the serial port that your dev board connects to, and we'll come back to this in a second. For this virtual machine, you're going to want to use TTY, this /dev/TTY USB 0 like it has right here. Now for the flash mode, again, like I mentioned, you're going to need to know, do you have a DIO or QIO board or chip right here? I happen to have a DIO one, so that's what I'm going to set here. If you're not sure, try DIO. This is probably what your chip is, and then I'll show you later what happens if you get this wrong. Now the flash size, this does matter. You want to make sure you get the right size. It defaults to 4 megabits. It just so happens my chip right here is 32 megabits, but actually 32 megabits is not supported by the flashing tool. So 16 megabits is the largest one that's supported. And it's okay if you have a larger size chip, you can use a smaller size here. The problem is if you had like a 4 megabit chip and you tried to use a 16 megabit firmware on it, obviously that's not going to work. So you do want to make sure that you get at least a large enough flash size for your chip that's on your ESP32 right here. And I do believe if you use smaller flash sizes, MicroPython might not compile in all of the features because it has to cut some stuff out sometimes. So just be aware, check the specs for your chip and see if you can figure out what size flash it has and try to use that largest size available. Now the last option here, cross compile, you don't need to set this. Unless you installed the ESP32 toolchain yourself and you put it in some special location, then you might need to set this. Otherwise, the Vagrant virtual machine set this up already ahead of time and you don't need to worry about modifying anything. Okay, so I'm going to save this file. You just press Control-O to write out this file and then Enter, and then Control-X to exit out of the Nano tool. And okay, so we're ready to compile this code, and so all that you need to do is just run the make command, and this is going to go and start compiling the code. You might notice it actually gives a warning at the top right here. It says the git hash of the ESP IDF does not match the supported version. The build may complete, but who knows if it's going to work. So this warning is there, and I'm just scrolling back down. You can see it's compiling everything right now. This warning is there because apparently Damien, as he was creating the ESP32 port, because the ESP32 is still a pretty new chip and the toolchain itself is still stabilizing, I think he noticed that there are bugs in the toolchain. And so if you really want to make sure that the code is working the way that Damien has seen it work, then he seems to snap against a specific version of that Espressif IDF. Now he explains in the README how to check out a specific version. So you can look at the make file and find out which hash it was compiled against of the IDF, and then check out the version of the hash for it. So if you run into real big problems, you might try that, but I was trying it and it looks like the current version works. So, fingers crossed that it'll still keep working. But just be aware, the toolchain itself might have issues, and so you might need to go in and check out a specific version of it. So okay, so it's going through, it's doing its thing, it's building all of the MicroPython source code right now. And if you run into errors, if you run into an error like, I can't find this extensa GCC command or something, then you probably had an issue installing the ESP32 toolchain. So go back and double check and make sure you got that installed correctly. For the Vagrant VM, it should hopefully work because it does that automatically, but if you did it yourself, then it probably can't find the compiler. Okay, so that compiled the code, and now the next step is we're going to load the firmware, and the firmware itself is in the build subdirectory. There's a bunch of files that are in here, and I'm not super familiar with ESP32, but apparently it's certainly more advanced than the 8266, and so there are 3 binary files that are created. Apparently there's an application binary file, there's a partition binary file, and then there's one more file, the bootloader binary file. And I think all 3 of those have to be flashed onto the chip to make it run because it's a much more advanced chip. I think it's running like a small little real-time operating system. So all of these parts have to be there. Luckily, the make file in this ESP32 MicroPython port does all of this kind of for you. It uses that esptool.py. That's the same tool. It's actually used to flash the ESP32 in addition to the ESP8266. But a lot of this is hidden from you, but it's just interesting to know that it's there, and that if you really want to start messing with it at a low level, you can start looking at what it does. Okay, so the next thing is I've got my chip and it's connected to my computer, but I want to flash this chip from within the virtual machine. And so this chip, this board is not visible to my virtual machine right now. It's only visible to the host computer, my Mac, and it's not visible to this virtual machine. But we can do this special thing called a USB pass-through with VirtualBox and make this board visible to my virtual machine. And I actually, in the Vagrant file, I turned on an automatic, I turned on USB support. I didn't turn on automatic pass-through yet because it's going to differ based on your board. So for this board, it uses a Scilab's USB serial to USB chip. So that's a pretty common one. We actually use it in like our ESP8266 Feathers and all kinds of other boards. But other ESP32 boards might use completely different USB to serial chips. Or maybe they don't even have a USB to serial chip and you've got to use like an FTDI cable or something like that. So, you know, doing this USB pass-through might differ based on what type of USB to serial chip that you have. So I'll show you in general how to turn on USB pass-through for a virtual machine though. So with your virtual machine running, you want to actually run VirtualBox because you have to install VirtualBox. That's actually the tool that runs the virtual machine. But I'm going to run VirtualBox and this actually shows all of my virtual machines that are installed. And right here is my running virtual machine, this ESP8266 MicroPython Vagrant virtual machine. And if I right click this and go into settings, even while the VM is running, there are a few settings that you can change. You can't change all of them. You have to usually turn off the virtual machine, like halt your Vagrant VM, and then you can go in and change all the settings and then start it back up. But luckily, if you go into the ports configuration and then the USB setting here, you'll notice that it should show that enable USB controllers turned on with USB 1.1 support. If you don't see that, then you probably didn't upgrade your Vagrant file. So make sure to upgrade that. You know, pull down the latest version from GitHub, re-provision, reinstall it because it will flip this on automatically. And you might need to install these VirtualBox USB extensions. I mentioned in the guide how to do that, but I think for USB 1.1 you don't need to do that. Anyways, with the board plugged into your computer, in this USB configuration, there's this USB device filters, and this is a setting that can basically say whenever a device is plugged into your host computer, if there's a USB filter set up for it, it will grab that device from your host computer and connect it to the virtual machine. And so your host computer won't see this device anymore. So my Mac won't be able to see this ESP32 dev board, but my virtual machine will. And so that's what I want. I want my virtual machine to be able to talk to this thing. So I want to click this little plus right here, and this is going to show all of the USB devices that are connected to my computer right now. And you can see there's a lot of video stuff because I happen to be live streaming off of here, so I don't want to click these little Magewell things. That's actually what's capturing my cameras. But the Silicon Labs USB to UART bridge, that's what my ESP32 is connected to. So if I click this thing, it's going to add a little pass-through automatically for my board. So I'll click OK, and it saves that setting, and then I close out of this. Now, what I can do if I run LSUSB, this just lists all of the USB devices that are connected to your Linux machine, and it doesn't show anything. It shows this root hub, which is kind of the default, I think, that Linux creates. But here's the thing, the USB device filter only applies when a device is connected to your machine. So what I need to do is disconnect it and then connect it again. And then I'm going to give it a second here, and if I run LSUSB, hopefully in a moment here we should see this thing reconnect. Uh-oh, maybe it's not working. Maybe I need to restart my virtual machine. Okay, well let's try this one more time and see if we can get this thing to work. So the USB pass-through is always a little tricky with virtual machines, I've noticed. The other thing I'll show you too is that, and I forgot to mention this when I showed the USB pass-through. So okay, so I set up this USB pass-through. If I double click this shows all these settings. For some reason, it just defaults to filling in all of this information, which I'm not sure if the USB filter looks at exactly all of this info, and if this serial number has to match up exactly, and then it applies this filter. So what I like to do is I just delete all of the info that the pass-through gets set up, basically. So I delete like serial number, product, manufacturer, revision. Just keep the vendor ID and the product ID. These are the only two things that matter, because that's how it identifies this USB device. So delete everything else. And I'm actually, let's just even change this name at the top. I think this name is just a pretty name that it prints, but we'll just say ESP32 instead for this. Okay, let's save that. Let's say okay. And now let's see, let's close this out. And then let's disconnect and reconnect and see if this fixes it. And if this doesn't do it, then we'll shut down the virtual machine. We'll start it back up, and that should hopefully get the pass-through to work here. There we go. Okay, so I just ran LSUSB, and now notice there's this signal integrated product CP210X UART bridge. Also kind of funny, you called it the MyAVR, my smart USB light. So someone somewhere created a smart USB light using this CP210X chip and committed it to the Linux kernel, and that's what it's called now. So anyways, though, you want to see this device, and even better, if I run dmesg, the dmesg command, this gives you the kernel output log, and this is showing you that it noticed that there was this USB device connected right here. And then even better, it shows the USB serial kernel module. Notice that, oh, this is a USB to serial chip. I'm going to go and create a serial port in your Linux machine. Oops, I just scrolled up on accident. And you can see this very last line right here saying, okay, I'm going to attach this USB to serial chip to the TTY USB 0 device. And so if I actually if I list all of my TTY, all of my serial devices on my virtual machine, there we go. There's dev TTY USB 0. So that is the USB to UART chip that's connected to my ESP32. And so now my virtual machine can see my ESP32 dev board right here. So again, long story short, this is just setting up a pass-through of this USB device to my virtual machine. So if you're using a different dev board that doesn't use that CP210X chip, you might need to do something special. You might need to have like a driver installed in Linux. Like this CP210X, it's already available in the Linux kernel, which is kind of nice. So I don't need to install an extra driver. And for FTDI chips, I think those are installed in the Linux kernel by default. But who knows? If you're using something esoteric, it might not be in there. You might need to do some extra steps or whatever for it. So you probably want to Google around for that and see what you need to do. Okay, so now that we have this thing ready, we're almost ready to install the firmware. So, we'll go back. I'm in that ESP32 folder of the MicroPython ESP32 GitHub repository. We ran the make command that built the firmware. And so the next step is, it says the very first time you load your firmware, you probably want to erase the firmware that's on your ESP32 chip. And so to do that, you run the make erase command. But before you can do that, with the ESP32, just like with the ESP8266, before you can send it new commands or firmware or use the esptool.py command, you have to put it into its bootloader mode, right? It's not even really technically a bootloader, but you basically, for some of these dev boards, have to explicitly tell it, okay, I'm not running my program anymore. I'm ready to flash new firmware. And so for the ESP32 and for this dev board, what you have to do is you hold down the GPIO 0 button, which is the one that's to the right of the USB board, or the USB connector right here. So you hold down this button, and while you're holding that down, you want to tap the reset button, which is the opposite button over here. And then you let go of this GPIO 0 button. So it's exactly the same as the ESP8266. If you ever had an old ESP8266 dev board, you might have had to do this also with that. So with the ESP32, no surprises, it's exactly the same. So I'm going to do that. And you won't, at least for this dev board, I don't see any lights that light up or flash like some of the ESP8266s used to do. So you just kind of have to trust that this happens. So I'll hold down GPIO 0, I'll press reset, let go of reset, and then let go of GPIO 0. And so now it should be ready to accept commands. And so now we're going to run this make erase command. But I actually have to run this with sudo just because the USB port isn't set up right now for non-root users to access it. So it's fine. I'm just going to run sudo. So sudo make erase. And then this is connecting and it's erasing the flash memory, so this is good. And okay, so it just erased the flash memory on this ESP32. Now, if you run into an error at this point, like I can't find the chip, just go back step by step and make sure that you can see, for example, this dev TTY USB 0 device. If you can't see that, then there's probably a problem with the USB pass-through, or like the Linux kernel doesn't know how to talk to this USB device. So, just walk backwards until you figure out, what might be wrong here. Okay, so I did the erase, and then the next thing is to deploy the firmware we just built. So make deploy. So, and again, you have to do this little dance, I call it. So I'm going to hold down GPIO 0, reset, and then let go of GPIO 0. And now I'm going to run sudo make deploy. And this is going to go, and it's going to use that ESP tool. So it's writing out the firmware right now to the board, and it just takes it a moment here. So we'll give this a second. And then once it's done writing the firmware, we are ready to try it and see what happens. So, okay, so just wrote the firmware out. Now, even though it says hard resetting, I like to always just reset the board myself, so I'm just going to press the reset button. Now at this point, I should be able to connect to the REPL and party on this chip. The problem is, for some reason in virtual machine, the screen tool doesn't seem to work. So you would think that you could access dev TTY 11 at 115200 baud, and I should be able to get to the REPL on the board, but it doesn't work inside the VM for some reason. So what I do is I exit out of the VM, and then I want to run Vagrant halt because I want to stop the VM, because remember, it has that USB filter, so my virtual machine is the only thing that can see this chip right now. But if I stop my VM, then that USB pass-through will end because the virtual machine is not running anymore. So now my Mac can see the chip, and I'll be able to connect to it from screen on my Mac. So just some weird quirk. Maybe it's a problem with screen, maybe it's a problem with VirtualBox. I'm not sure why, but I can't seem to use the screen terminal from inside the VM. Okay, so that's shut down, and now on my Mac, I'm not in the virtual machine anymore. I should see that Scilabs chip. Yeah, so on a Mac, that Scilabs USB to UART shows up as a dev TTY slab USB to UART device. And by the way, you do have to install a driver on your Mac to make this visible. So it's the Scilabs, search for the CP210X driver, and you'll find an install page here from Scilabs. If I remember correctly, on OS 10 on Mac, you do have to install this driver, and on Windows, of course. On Windows, you have to install a driver for everything, but on Linux, you don't have to install it. So hey, use Linux, and you don't need as many drivers. So just word of the wise: if you plug this thing in on your Mac and you don't see anything at all, go install the driver. You're probably missing that. Okay, anyways, so now I should be able to connect to this dev tty.scilabs 115200 baud. And okay, this is cool, there's nothing. Let's press enter, and hey, look at that, I've got a REPL. So this is probably MicroPython. If I press Control D, D as in dog, this is gonna do a soft reset, and look at this. MicroPython version 1.8.6 for ESP32. Hey, that's pretty cool. It looks like it's working here. So let's try some MicroPython. We'll say print, how about hello world? So do that. It works. We got MicroPython. I can import the machine module, because remember, this is MicroPython with the upstream that uses the machine module. This is not CircuitPython. Eventually, we probably will have a port of CircuitPython to the ESP32, but not yet. So for now, you want to go and use the machine module. Now, you might notice I have a little LED connected right here. So I have this wired up to GPIO 17. And like I mentioned, you probably want to go to the ESP32 Arduino GitHub repository page, because this has a nice little pinout right here. So GPIO 17 is what I have this connected to. And so if I want to blink that LED, I can say, okay, let's make an LED object. Oops, LED equals machine.pin, pin 17. That's what I have it connected to. And let's make this an output. Oops, like that. And then if I set the value of this to true, hey, check that out, the LED turns on. And if I set this to false, LED turns off. So, and if I want, I can like import the time module, make a little loop, and we can say LED.value equals true. How about time.sleep for a second? LED.value equals false. Time.sleep for a second again. And then if I press enter 3 times, then hey, look at that. We've got a blinking LED in MicroPython here on the ESP32. So that's pretty cool. And then I can press Control C to break out of that loop. So that's cool. I mean, it works. There's enough there to use the digital I/O. Now, if I go back to the ESP32 GitHub repository, it does mention that the Wi-Fi support is there. I haven't tried it yet, but in theory, I don't know. Let's try. Is it the WLAN module? I forget what the module name is. Let's see. Okay, let's go to this quick reference. Let's try it out. Let's go for broke. I want to see if the Wi-Fi works on here. So it's supposed to be the same as on the ESP32. Oh, it's the network module. That's right. Okay, so let's import network. Okay, that's cool. Now you might see this. I think this is debug output that you get from the ESP32 RTOS, or the real-time operating system that's running. So again, this is all in development, so I'm sure you'll see stuff like this in the console. So you can just kind of ignore it for now. Okay, so the network module. Let's create a WLAN interface using the station interface. Okay, so let's paste this in. And now let's do, how about WLAN.active true? Okay, so we turn on this interface. And then let's do a WLAN.scan. So let's see if we can scan for our wireless access points. And okay, so it's doing something. Okay, yeah, so it looks like it just scanned for all of the wireless access points, and it's listing all the nearby ones here. Interesting. Tony-office.a. I don't have a wireless network called Tony-office around here. Huh, I don't know, maybe someone's trying to, or maybe I do and I don't know it apparently. So interesting. Maybe that's my Mac. Huh, I don't know what that thing is. I'll have to mess with that later. Anyways, so it looks like wireless is working. It can scan. I'm not going to connect to my network, although if you've watched my previous streams, you know the password to it, so we could connect. But anyways, it looks like there's enough stuff here to start playing around with the ESP32 and start playing with some of the network things. I think it does mention in the GitHub repository things like I2C support are implemented. Basic GPIO support is implemented there also. So, you know, give it a shot. It might be ready to start playing with. I don't think it's as complete as the ESP8266 port, but there's enough there, I think, to play with and get started with. Okay, one quick thing I'll show real fast is what happens if you get that QIO and DIO thing wrong. So I'll quit out of here, because if you're lucky, you'll get the REPL like this and everything will just work. If you're not as lucky, you might not get the REPL. And so let's turn my virtual machine back on. I'm going to run the Vagrant up command, and I'll reconnect, and we'll rebuild it using the wrong settings. And I'll just show you what happens when you flash it to your board and then you try to access the REPL. You'll get in. You won't get the REPL, but I'll show you there's some interesting debug output that you'll notice from the operating system on the ESP32 that might give you a hint that something's wrong for this. So I'm just letting this thing turn on the virtual machine again. Okay, so let's connect to the virtual machine with Vagrant SSH, and let's go back into the MicroPython ESP32 repository, and then in that ESP32 subfolder, and then let's edit that make file, lowercase m make file, and let's change this to flash mode QIO instead of DIO, which is wrong for this chip, but let's just do it. And then let's rebuild the firmware. I'm going to run make clean just to clean out the old firmware, and then let's run make again just to rebuild the firmware. And I don't even think I need to rebuild the firmware when you change that QIO DIO thing, because it just changes how it flashes to the chip, but it never hurts to clean and rebuild the firmware here. Okay, so we'll give this thing a second, and then we will reflash. I'll erase the firmware and then I'll flash it again, and we'll see what happens here in a second. It's just building all of the MicroPython source code right now, and in a second here it should finish up. So it's linking in, or no, it's building some of the last few things and some of the components here. And it looks like we're close to being finished. It's compiling. Yeah, there's this free RTOS, which I think is the real-time operating system that it uses internally on the chip. And then LWIP, that's the lightweight IP protocol. It's an implementation of the TCP IP protocol, but it's a small one that you can embed embed TLS. This is basically SSL support. Excuse me, comes from this embed library. So just like the ESP8266, this I assume has things like SSL support just because it's using that same code. So it'd be something cool to play with later with the ESP32 is to see if you can do stuff like more advanced IoT projects that use SSL and all kinds of fun web services and stuff. So okay, we're almost done here. There we go. So it's linking in the final thing. And now let's do, okay, so I'm going to do that little dance to put it into the programming mode. And then let's do sudo make erase to erase the flash memory. So it's doing that. And then I'm going to do that little dance again. Hold GPIO 0, reset. And then let's do sudo make deploy. And let's flash the firmware that I've built with the incorrect settings for the flash chip. So this is using this QIO. It's like a quad speed SPI versus the DIO, dual speed SPI. And apparently there is a hardware difference. Like you need more lines for that QIO mode routed to your flash chip. And it wasn't actually kind of interesting. I don't have a link here, but I looked up the datasheet for my flash chip, and this chip does support that QIO mode, but I don't think it's wired up that way, and so that's why I have to use the DIO mode. Okay, so I did that. I just flashed it. I'm going to reset the chip. I'm going to exit my virtual machine. I'm going to turn off my virtual machine. We'll say Vagrant halt. And then I'm going to connect in screen real fast. So I'm going to try to connect to the REPL, and we'll see what happens here in a second. So let's go screen dev tty.scilabs 11.200 baud. And okay, so I don't see the REPL. I press enter. I don't get anything here. I press reset on my chip. I can even do that. And I just get all of this info. This is actually kind of cool though. So this is the output of the RTOS, or the real-time operating system, on the ESP32. And you can actually see it's booting up, and it does show you, okay, here's this mode. It's trying to use that mode QIO. But you can see it's getting to this like load and then load -1. So I think what's happening is it looks in the flash chip for where it should continue loading the code that it wants to run on startup, like MicroPython or whatever. And I think because I don't have that DIO QIO set correctly, it's not able to read it the way that it expects, and so it's getting this junk data, and it just stops at this point. It doesn't know, it can't even figure out where to read MicroPython right now because it's not in the right mode to do it. So if you try to access the REPL and you see something like this, you probably got that QIO DIO thing wrong. So try swapping, to the other option. So, in this case, QIO is not what I want, DIO is what I want. So I tried, I go back, rebuild with that, and it should work in that case. So just wanted to call that out because that tripped me up, and it's not really obvious when you look at this, at your chip, what mode it uses. If you're lucky, the product page or the data sheet will probably tell you, but if you're not lucky, you might just have to try it yourself and see what works for this. So, okay, so I think that's it then. I'll wrap this up. This is about an hour long, so we'll finish this up. Again, I just wanted to show how to use the ESP32 port of MicroPython on the ESP32 dev board. So the ESP32 is the new version of the ESP8266 from Espressif. It looks like it's going to be really popular. I bet this will probably be a very popular year for it. Like I mentioned, the Arduino IDE has a port that works with it, so you can program this chip with Arduino. And there's a port of MicroPython now that looks like it's complete enough to start using. So like I said, there's no pre-built firmware. You're going to have to follow this video to build the firmware. But as I showed in the video, it's really easy if you use this little virtual machine. And then it looks like there's basic support for things like Wi-Fi, so enough to start doing some projects on here. So if there are any questions, maybe throw them into the chat, and we'll get to those in a second. I'll go back to the main view real fast. So yeah, there's the main view there. And I don't see a lot of questions. Let's see. Oh yeah, could you set up TTY USB 0 for non-root access? Yeah, you can. For the virtual machine, I'm using Ubuntu. And I believe in Ubuntu, you have to add the user to the dial-out group, I want to say. So if you search online search for like dial-out, Ubuntu, non-root access, it should show you. It's like there's an add user -G option, I want to say, that adds a user to a group. And that should give you non-root access. But Honestly, I just use sudo and you know, it's the blunt, it's the big hammer. Everything looks like a nail. Just, you know, use it. It works because it always works. There's each distribution has a different group. Like, you know, in Debian, it's probably not dial out. It's probably something else. And in Arch, it's probably completely different. So instead of trying to sort all of that out, I just run with root as sudo, and it works fine. Or you could probably change that dev tty USB 0 device and tweak the permissions with chmod so that non-root users have access to it. That's probably another way you could do it. That's probably not the right way to do it. The right way is probably to add a udev rule so that when that USB vid and PID is connected, it automatically adds it to whatever groups, but it's such a pain. Just use sudo. So that's my advice. So okay, cool. I think that was it. So I'll wrap this up then. So thanks a lot for watching. Check out youtube.com/Adafruit. You can see this video and all kinds of other fun project videos there. Check out twitch.tv/Adafruit. That's where I like to do these live streams. And like I mentioned, I've been doing a lot of MicroPython live streams and CircuitPython live streams. And today I figured I'd take a little break and we'd do an ESP32 MicroPython live stream because there's a really cool hack chat just about an hour ago on hackaday.io where they talked to Sprite TM. He's one of the guys that works at Espressif and works on their, I believe, like the toolkit, and he helps make all the ESP32 magic. So I figured, oh, it's a good time to check out ESP32 MicroPython in this live stream. And I'm sure if you're watching this video later, the state of the world has probably advanced quite a bit. So again, check out like the GitHub repository for ESP32 MicroPython. If any of these instructions have changed, it's probably going to be in the README there. So check that out. If you like this video, click the like or the comment, subscribe. You know, let us know that this is interesting stuff, and we'll keep doing stuff like this in the future. So until next time, this is Tony from Adafruit. Thanks a lot for watching. I'll see you later.